right, so the difference between an equal sign equation and an inequality solution is inequalities, there's an infinite number of solutions. There's not just one solution. Equal sign, there's one solution typically, or two solutions if you're talking about a quadratic, right, where we saw two solutions. So let's go ahead and practice solving these, and then we're going to go ahead and put the answers on a number line, because that's how we're going to do these quadratics. So x minus 4 is greater than 7. So this is just a linear inequality. So we're just trying to get x by itself, so we could add 4 over. So we get x is greater than 11. Right, and so we want to go ahead and put that on our number line. All right, and so this is an open circle at 11, right? And it's shading to the right because it's pointing to the right. Right. And so if you remember this, I think it was back in Unit 1, we kind of did this a little bit. And then we have the inequality answer, we have the number line answer, and then we want to also give it the answer in interval notation, right? And so let's go ahead and practice putting our answers in interval notation, because we're going to have to do this with quadratics also. So x is greater than 11. To kind of just work from left to right, so it first hits at 11 with parentheses, right? And then it's pointing to positive infinity. And so that would be the interval notation from 11 to infinity. All right, and then b, let's solve that one. So here we can divide both sides by 2 first. And so we get x is less than or equal to negative 4. And we can put the answer on a number line. So this is going to be a closed circle at negative 4. And it's pointing to the left, so we would shade to the left. Okay. And then our interval notation, working left to right, negative infinity would hit first, right, to negative 4 with a bracket. All right, so quadratic inequalities, real similar. We have to make sure we have our quadratic in standard form. We need 0 on one side. We're going to solve these by factoring. If it's not already factored, typically they set these up so they can factor. So we factor them. And then from the factors, we can give the solutions. The solutions are going to be the numbers on the number line that we're going to use as boundary points. All right, and then we're going to use test areas to see where it's true and where it's false for the inequality. And then where it's true, we shade that area, that interval, and then we can give our answer in interval notation. Okay, so this first example, x squared minus x is greater than 6. So we need to get 0 on the right side, so we're going to subtract 6 over first. All right, so x squared minus x minus 6 is greater than 0. All right, and now we're going to factor this. And since it's a trinomial, we can just use our x. So negative 6 on top, negative 1 on the bottom. All right, so that would be negative 3 and positive 2. So the factors are x minus 3, x plus 2, greater than 0. All right, so then we can set those equal to 0 and solve. And so we're going to get x is equal to 3 and x equals negative 2. All right, so these are our boundary points on our number line. So the next thing we're going to do is go to our number line, and we have to look at the inequality to see if there's an equal sign or not. Since this inequality does not have an equal sign, these two numbers are going to be graphed on the number line, but they're going to have open circles. All right, so both of them will have open circles. So negative 2, open circle, and positive 3. Right. So now we can see our number line has been broken up into 3 intervals. All right, so we have this interval on the left of negative 2, we have this interval in between, and then we have this interval on the right. Right? So this is where we can do test points to see which section it's true and which section is false. We want the true section. Okay, that's where all the solutions are going to lie. So one thing that helps a lot, I think it's the easiest, is always find an interval that has 0 in it. Okay, I would always use that one first because 0 is easy to work with. Right? So here's 0 right here, it's in this interval right here. And so I want to see if 0 is true or false for that interval. If it's true, that means every number in this interval would be true. If it's false, that means every number in this interval is false. Right? So, but you can take any point you want. Okay, 1 would work, 2 would work. It's the same answer, but 0. Okay, so if I use 0, all I'm doing is I'm plugging 0 back in. You can either go to here to plug it in, or you can go into the factored form to plug it in. The answer is going to end up being the same because the factored form is the same as the quadratic, not factored form. All right, so if we use 0, okay, so all I'm doing is putting 0 there, and I'm putting 0 there for x. So 0 minus 3 times 0 plus 2, is that greater than 0? Well, 0 minus 3 is negative 3 times 0 plus 2 is positive 2. And negative 3 times 2 is negative 6. So is negative 6 greater than 0? Is that true or false? It's false, right? Negative 6 is not bigger than 0. It's false. All right? So we know that this whole area here, that's false. Every number in that interval is false. Okay? So now I want to check the other intervals to see if they're true. So I can take any number I want. Again, if I start on this interval over here, I can use negative 3, I could use 4, negative 5, negative 6, negative 100, negative 1 billion. I could use any negative number on this side of negative 2 I want. Okay? It'll be the exact same answer, true or false. That's all I'm looking for. All right. So let's say I use negative 3. So now I'm plugging negative 3 in for both x's. Or you could put negative 3 in the standard form. It's up to you. All right, so if I put negative 3 in for both x's, negative 3 minus 3 times negative 3 plus 2, is that bigger than 0? Well, negative 3 minus 3 is negative 6. Negative 3 plus 2 is negative 1. Negative 6 times negative 1 is positive 6. So is positive 6 bigger than 0? Yeah. So this area is true. Right? So then I can test the point over here on this interval over here. So I could use positive 4, I could use positive 5, 6, 7, 8. I just can't use 3 because that's a boundary point. Okay, so you just can't use your boundary points. All right, so if I use positive 4, right? So 4 minus 3 times 4 plus 2, is that bigger than 0? Well, 4 minus 3 is 1. 4 plus 2 is 6. 1 times 6 is 6. And 6 is bigger than 0, so that's true. All right, so when we give our answers on the number line, so I'm going to get rid of this, we shade all the true areas, right? So this area right here is true. This area over here is true. And the middle part is false, so we don't shade that area. All right, so here's our answer for the number line. Now we have to give the answer in interval notation. All right, so we did this in Unit 1. Right? So we have this interval we're going to give, and then we have this break, number U, the union, and then we have this interval over here. All right, so our answer would be negative infinity to negative 2 union positive 3 to infinity. All right. Example 2 is already done. We already did it. It's exactly the same answer. I mean, factored anyway. So let's go ahead and plot the solutions though. Okay, so it's already factored, already have 0 on one side. So we know that our boundary points are -2 and +3 again. Now this one has the less than or equal to, so we have to do closed circles this time. Yes? Well, you're setting, remember, when you have factors and you want to solve them, you set it equal to 0 and solve it. So you have to subtract 2 over. So that's how you get -2. Right? So again, it's just like how we did with factoring with equal signs. And when we have the factors, now how do we get the solutions? See, x plus 3 equals -2. Over here, okay, when we have our factors, how do we get the solutions? Okay, -x minus 1 for the solution. So it does just change that. All right, so we have a -2, so this is going to be a closed circle because of the equal sign, less than or equal to. +3 is going to be a closed circle again. All right. All right, so now, just so you can see, everything's just reversed because the inequality is reversed. So if I try 0, okay, so I'm going to plug 0 in for x and see if that's true or false. All right, so 0 plus 2 times 0 minus 3, is that less than or equal to 0? So 2 times -3 is -6. Right? So -6 is less than or equal to 0, that's true. So this whole area, this interval, is true because 0's in that interval. Now, one thing that's nice about quadratics, and we're going to extend this in Unit 3 when we get to polynomials, is once you find an interval that's true, the other intervals are false. Okay. But you have to make sure your math is right, because if you mess up, there's no way to check it. So the only way you check is test another point and make sure that it's false. So if you know it's true here, then you know it has to be false here. Okay? If it's true out here, then it has to be false in here. Right? So again, I can test just to make sure. I'll use +4 as my test point. Right? So 4 plus 2 times 4 minus 3. So that's 6 times 1, which is 6. 6 is less than or equal to 0. That's false. Okay. So my true area, or the interval, is right here. And so now I have to give the answer in interval notation. Right, so this is going to be from -2 to +3. Yes? Yes. Uh-huh. Yep. And the way these work also is they alternate. False, true, false, true, false, true. So if you know this is false, and this is going to be true, and this is going to be false. Okay. If this is true, and this is false, and this is true. All right, example 3. Solve -x squared minus 3x plus 4 less than or equal to 0. All right, so we want to factor this. All right, so what I would do is, because you're leading off with a -1, I would factor the -1 out first. So all the signs are going to change. All right, and now we're going to go ahead and factor this trinomial on the inside. So -4 on top, +3 on the bottom. So two numbers that multiplied -4 but add to 3. 4 and -1. All right, so our boundary points are going to be at -4 and at +1. It's less than or equal to, so we have to put the equal sign, close the circle. So negative 4 is over here. Positive 1's right there. All right. And so we have our three intervals. Okay, we have this interval on the left of negative 4, the middle, and then the right of positive 1. Right. So again, always test 0 if you can't. And you can see zeros in the middle here. We have negative 1 times 0 plus 4 times 0 minus 1. And we want to see, is that less than or equal to 0? So negative 1 times 4 times negative 1. So negative 1 times 4 is negative 4. Negative 4 times negative 1 is positive 4. So is positive 4 less than or equal to 0? Is 4 smaller than 0? No, 4 is bigger than 0, right? So that's false. So this area is false. 4 is not smaller than 0. So we're looking for, if it's smaller than 0, that means it has to be negative. It has to be some negative number to be true. Because only negative numbers are less than 0. Okay, all positive numbers are bigger than 0. Okay. So this area is false. It means this is our true area. Again, we could test it and see. Right? So I would throw in like a positive 2 or a positive 3 just to test it and make sure. Okay, so here I'll use positive 2. So negative 1 times 2 plus 4 times 2 minus 1. Is that less than or equal to 0? Negative 1 times 6 times 2 minus 1 is 1. Negative 1 times 6 is negative 6. Negative 6 times 1 is negative 6. So negative 6 is less than or equal to 0. That's true. So that means the other side's true also. So when we graph, we have that area, and this area. So then our interval answer would be negative infinity to negative 4 with a bracket, union, positive 1 to positive infinity. Yes?
So I'm doing, for example, 2, I tried using negative 3 to see if it was true or false, because it must be false. And I ended up getting it was less than or equal to 6.
Okay, so example 2, which number did you try?
I did negative 3.
Negative 3, okay. So let's see. Negative 3 plus 2 times negative 3 minus 3.
And I got true.
So negative 1 times negative 6 is 6. So is 6 smaller than 0? That's false. Okay. All right, so go ahead and do example 4. See if you can factor that. Okay, it's a trinomial. Got to use the x.